Okay, now, ladies and gentlemen, we are going to begin with the next session right now. Now, welcome back. I hope that you had a great session over lunch. A lot of you were talking and networking away. You forgot about the time, but that means good things, right? It means you guys are having a good time together. All right, now, first session after lunch, we'll be bringing Mate Fejes back on stage again, and this round, we will be conducting a demo. All right, as you can see, we have some of the props being set up. And with that, ladies and gentlemen, we're going to start with the demo called Digital National Identification. So Mate, anytime when you're ready, over to you. How about we put our hands together for Mate? Thank you.
Hello, good afternoon. Work? Sounds like it does. Hello, good afternoon. Hope you enjoy your lunch. It's me again. This time, we would like to continue with some workshops, some live demonstrations of biometric solutions. We are going to start with complete biometric solution for national registry, national identification. I also would like to invite my colleague Fatih to the stage.
Thank you.
So we'll deliver this demo presentation to you together. What we are going to do today is a kind of simulation of national registry or national identification for ID card issuance, which is a more traditional way of using biometric technologies for national identification, followed by something we call digital national ID. So these are the topics that we started to discuss in the morning session. Or can we go back to the slide? Sorry. So what we're going to do, quick outline, a very high-level overview of this demonstration. We're going to start the story. Let's make a story out of this. We are going to start a story at a government office where a citizen approaches the counter supervised by this operator, this government employee, to apply for a national ID card. This national ID card application is performed in a very, we can call it old-fashioned way. It's not a bad word, which includes complete biometric enrollment of fingerprints, faces, and faces, only one face, with a bit of luck, and irises of the citizen. This is followed by collection of some personal information, optionally some attachments. It can be a birth certificate, it can be a soft copy of other documents, and so on. And eventually, this application is sent back to a government-owned data center. This government-owned data center hosts an ABIS, an automated biometric identification system. Government authorities like National Registry, for example, use ABIS to create their source of truth. Since these authorities are the ones issuing the ID cards, they are not able to rely on other identity documents because they are the ones determining who is who and which identity is a true identity, which identity is not a true identity. So to build this single source of truth, these authorities use biometric deduplication. Biometric deduplication means, or the word deduplication means getting rid of duplicates, removing duplicates. So we use biometric one-to-many matching of the enrolled face and fingerprints to search for duplicates, to make sure that that person does not have another record in the system, or that person does not have another valid ID card already issued. So once this deduplication is done, and it's proven that the person is unique, so let's say in our story that this person is applying for the very first ID card. This person just turned 18, or depending on the country, right? So this person is going to apply for the very first national ID card. Once everything is approved, the registration is unique, this ID card will be printed and delivered back to the citizen. Then we are going to continue our story with a digital national ID kind of scenario, which does not have to happen at the government office or at the data center. It can happen literally anywhere, where our citizen will use the issued national ID card with biometric technology empowered mobile application to activate a digital national ID token. And using this digital national ID token, the citizen will be able to apply for government services and other services remotely and to perform digital transactions in a touchless manner using only their cell phone. So let us start with the first part of this scenario, which is the very first application for a national ID card. We are going to simulate this first step at this venue here. Let's say this is our government office. This government office is equipped with a PC and with all the biometric devices that we need. A fingerprint scanner, a 442 fingerprint scanner, a face and iris camera. Optionally, there can be a card printer which prints the card immediately, or there can be a document scanner to attach some documents and so on. But this is the basic must-have equipment for a full biometric enrollment. And now let's proceed with the actual demonstration. What you can see here is the actual product. This is not a mock-up, this is not a simulation, this is not a video, this is the actual solution, this is the actual product which we offer. This is Biometric's ABIS. As you can see, this is a fully web-based user interface, which makes it very lightweight. You don't have to install a very heavy application on a PC. It really only requires a web browser and a very simple service running on this computer, and the computer connected to all these peripherals. And we have our first citizen here today applying for a national ID card. Let me introduce our citizen, Fatih.
Hello.
So Fatih just approached this counter operated by me. I'm the supervisor. I'm the government employee at this government office. And we are going to perform an enrollment. We are going to start this enrollment with capturing Fatih's face. What you can see on my screen here, this is what the operator can see. This is a supervised scenario. This is very important. The first scenario is supervised, which means it's operated by this trained supervisor, operator. So what I can see here, this is my feedback screen. This does not necessarily have to be visible for the enrollee. What we can see here is a real-time quality assessment of the face. This face now is being detected and being tracked in real time. Now we can see that the first indication is that face is out of bounds. The face is too close to the camera. So now we are going to give some instructions to our citizen to move a little further from this camera. Now we are going to continue our real-time quality assessment before we capture this photo. Let me mention one very important thing. In biometrics, in any kind of biometrics, quality assessment at the enrollment site on the spot is absolutely crucial. You can have the most accurate biometric engine on your backend. If the input quality of the input image is poor, it will always be garbage in, garbage out. And there is no way to fix it. So very good quality QA, quality assessment at the enrollment site is absolutely crucial. The quality assessment in this case is implemented based on the ICAO standard. The ICAO standard, as we all know, is the standard for visa photos, passport photos, which is very, very strict when it comes to the quality of the photo. It is up to the government's policy how strictly they want to implement this ICAO standard, but the information given by the system to you is always complete. So first of all, on the right-hand side of the screen, I can see the so-called behavioral ICAO attributes, which are being evaluated in real time, starting with the head position, head rotation, yaw and pitch angle. We can see some of those icons turning green, red, or yellow based on the position. Of course, a full frontal position will result a green icon on all three angles, then followed by the mouse status, which should be closed, the eye status, which should be open, and so on, whether there are multiple people present in the photo, etc., etc. On the left-hand side here, you can see the so-called environmental ICAO attributes. Those are not easy to fix on the spot. We have to set up a right environment for that. So there is sharpness, there is brightness, there is color profile, there is contrast. Obviously, this is not a perfect environment here. The lighting conditions are not perfect. The background is not unique. So obviously, we won't be able to fix all these parameters. But as I said, these are only indications given to the operator. It is always up to you or the respective government agency how strict they want to implement the ICAO standard. Now I'm going to capture this photo. Once the photo is captured, it is cropped and rotated to a normalized position according to the ICAO standard. We have a review screen here to review all the ICAO attributes. So we managed to keep all the behavioral ICAO attributes within the standards defined range. Of course, we were not able to fix all the environmental ICAO attributes. There is a little bit of shadow on one side. The sharpness is not perfect. The background is not perfect as well. It's not bad, but it's not perfect. But for us, this is perfectly fine. Let me also touch that for accurate face recognition, this photo is perfectly okay. Even much better quality, even much worse quality photos are perfectly fine for accurate face recognition. This is really about your policies, whether you want to have a full ICAO compliant photo or not. So once we capture the photo, we are going to continue with the next biometric modality, which is iris scanning. This time we're going to use a touchless iris scanner, which is different from the next demonstration, which is law enforcement. In law enforcement, we're going to use not a touchless iris scanner. We are going to put a higher focus on accuracy and quality and neglect convenience. This time, this is a civil use case, so we keep the convenience in mind as well. So we are going to use a touchless iris scanner. We proceed to the next step, and once the scanner is initialized, I will ask my citizen, Fatih, to look into the scanner. This brand of the scanner gives some audio instructions to the user to move closer, to move back, to look into the camera, and so on. Of course, there are plenty of other models. Let me also mention that this solution that you can see here is completely hardware independent. So we are using a fingerprint scanner from vendor A, and this iris scanner is from vendor B, and this camera is from vendor C, but we can use any other fingerprint and palm print scanners from vendors D, E, F, G, and so on, which we already integrated. Okay, irises are captured. Again, quality assurance is very, very important. In this case, we do not have a standard like ICAO, so we only rely on some of the proprietary quality metrics, which are indicated here, and also quality metrics provided by the scanner. Next step is capturing fingerprints. We are going to capture fingerprints in a 4-4-2 manner. So first, I will ask Fatih to place the right 4 fingers on the scanner. This is a real-time preview of the fingerprints with real-time segmentation and tracking of the fingerprints. Now we're going to continue with the left hand. Again, the fingerprints are displayed as a real-time preview, automatically detected, segmented. The quality is checked in real time, and when the quality is good enough, according to the system, the automatic capture is performed. We are not clicking any button here. The quality assessment is completely automatic. Let me tell you a few words about what just happened here, because it was very fast, very smooth, which is the way it should be, but there was a lot of different real-time checks happening in the background. First of all, we were checking right hand and left hand. The system would not accept left hand instead of right hand. So when right hand is expected at the first step, left hand is not accepted. The system automatically detects the relative position of these 4 fingers, which is always the same. If these relative positions are different, the system does not accept it because it's not the correct hand. Second, we were performing sequence check. So within these relative positions, we were performing checks and detections of the fingerprint positions to make sure that the right index finger is flagged in the system as right index. and the right middle is flagged as right middle. So all those positions are not shuffled. Then we also performed a quick fingerprint duplicate check. First we captured these 4 and these 4, right? And then we captured these 2. But at this step, it's not possible to detect whether these 2 fingers are the thumbs or the indexes or the pinky fingers. The only thing that we can do is to do a quick matching of these 8 against these 2. If there is any duplicity, it means that these 2 fingers are not the thumbs, but are some of these 4. Having these precautions or quality assessment techniques in place, we can achieve actually a lot. We can achieve that we know exactly which finger is right thumb, which finger is left index, which finger is right ring, and so on. This gives us a lot of advantages at the backend side, at the server side, because we don't have to cross-check fingerprints. We don't have to match all fingerprints with all fingerprints. It's enough to match right thumbs with right thumbs, which saves a lot of processing power and reduces the cost of the server backend. Apart from that, there are different qualities which are measured here. Here on the left-hand side, you can see the NIST qualities. These are the standardized qualities. This is a tool, an SDK, which can be downloaded from the NIST website. So every vendor uses the same implementation, the same SDK, to calculate NFIQ1 and NFIQ2. These are 2 different qualities. These are used mostly for interoperability, to compare which system captures better quality fingerprints, because the measurement tool is the same, applied on vendor A and vendor B. On the right-hand side, you can see the Innovatrix proprietary qualities. In this case, we measure the fingerprint placement quality, which checks whether the right part of the fingerprint is placed on the scanner. If this is my fingerprint scanner and this is my finger, this is a right placement. This is a wrong placement. This is also a wrong placement. All these different placements are detected by the Innovatrix placement quality. The other value in the right bottom corner of this picture is the so-called fingerprint image quality, which is affected by the pressure I make on the surface of the scanner. And what is very important is these 2 qualities are independent. I can achieve good placement quality with low pressure, which results into low image quality. Or I can press the tip of my finger with very high pressure on the fingerprint, which result into on the fingerprint scanner, which results into high image quality but low placement score. That's why we have to measure both the right part of the fingerprint on the scanner with the right pressure. Of course, if any of these fingerprints are something we are not happy with, we can always retake them. At the last step of this enrollment, I'm going to collect some personal information from Fatih. This, of course, is always the first part of the system which is completely customized. Every government agency wants to collect a different set of personal data with different attachments. This is always completely customized. For the sake of this demo, we have a simplified version with an autofill button which automatically fills some information, and these are some dummy personal information. Okay, our enrollment is done. The last step is a quick review screen where we can take a look at the photo we've taken, those irises that we've taken, and all 10 fingerprints along with the personal information we collected. Once we're happy with this enrollment, we're going to submit this enrollment to our biometric backend to make sure that this person does not have another valid identity document. Now I'm going to submit this enrollment, and now I'm going to be redirected from this local screen here to the detail screen of this person in the biometric backend system. So what I'm going to see here now is that Fatih is enrolled with all the information that we collected, and the system says this person is unique. Unique means the biometric deduplication, the one-to-many search of all the fingerprints, faces, irises, and so on that we collected were searched in the entire database, and there was no duplicate found, which means, yes, it's true. This person is applying for the very first identity card, is eligible for an identity card, there is no duplicate, there is no other identity card with different personal information, for example. So our decision at this case This case is, of course, to approve this request and to print a national ID card, which let's say now is printed. Fatih received his national ID card. So now Fatih is a national ID card holder, which means, of course, he can visit a government office, he can present his ID card along with his face to this government employee. This government employee can take a look at the card, can take a look at his face and approve a service that he's applying for. Or he can be a bit more modern and futuristic, and he can move to the next stage, which is a digital national ID. So now he doesn't have to be at the government office, he doesn't have to be at the data center or the central location or wherever. He can be literally anywhere with his national ID card and his smartphone, which he already downloaded this national ID application. So what Fatih is going to do now is the following. He's going to use this mobile application to activate a digital national ID token, which is a government-endorsed identity reference in a digital form. He's going to perform the following steps. First, he's going to use this mobile application and his ID cards to capture a photo of it. This is going to be an automatic capturing of the national ID card, making sure that there is proper quality assessment and so on, right? So the system will capture this ID card automatically. Once this is done, this backend system will extract all the personal information from this ID card, also making sure that this ID card is valid, so the national ID card number or the national ID number, the card number, any identifier which is extracted using OCR from this card will be cross-checked with the government backends. This is why we don't really need document authenticity check in case of digital national ID. So once we have all the personal information from Fatih, we have to make sure that he's the real owner of this ID card. He's the real owner of this personal information. So the next step will be capturing a selfie. Simple as that. But behind the scenes, there will be many, many things happening. There will be quality assessment with some instructions and automatic capturing, making sure that he's not taking very bad quality selfies and all the important biometric information can be extracted. But in the meantime, liveness check will be performed. The first step of the liveness check will be very seamless. We call it a passive liveness check. You won't even notice, but there will be a liveness check performed on that one single static photo, which is taken by Fatih. Then later we will demonstrate it on a spoofing attack. So you will see how we can detect non-genuine faces, fake faces instantly. The next step will be the second phase of liveness check, which we call the magnify liveness. This will be partially active, not completely passive from the user perspective. He will have to zoom in one of his eyes. This checks a few more things. A little bit of checks in terms of different distances. So checking the face from different distances, the distortion of the face when the distance from the camera changes, a little bit of eye biometrics, and a few more things which I'm not allowed to mention because it's our IP. And of course, the last step will be an identity verification, which is a face matching against the ID card, and of course, the backend photo in the backend system, not only the ID card. This is a very important difference between eKYC done by banks or so-called eKYC done by the National ID Authority. This makes it much more powerful. So these steps are going to be performed by Fatih right now. I'm going to share Fatih's screen so you can see what's happening on his cell phone.
Okay, thank you, Mate. So what you guys are seeing on the screen right now is what I have on my phone. This is a demo application of our digital onboarding toolkit. Of course, if you guys are in the market for creating your own applications, this is just meant to serve as the front end of what your users see. If you want to change it to any different colors or any different buttons that you want to use, you want to put a different logo on it, that's completely possible. But let's get straight to the point and perform a full onboarding as what was described in the slides just now. So there comes with some instructions for you guys or for your users. For example, they will tell you to scan your identity document, take a selfie, and of course, the liveness check. So I click on Start Onboarding, and there are more tips to help your users or your end users complete a successful onboarding. Things like cleaning the camera lenses, making sure you have a camera for your phones, because some users don't have working cameras, and that's completely understandable. Make sure you are in a good environment where there's good lighting, and make sure that, generally you are in a presentable manner. Okay? Now let's continue to the onboarding. Now it's showing scan document, and it's telling me to place my document in the rectangle. I will try from a very long distance, and there will be the onboard instructions. Move closer, move closer. I don't have to press any button. It will automatically capture the document once it is at a suitable quality. And again, this is what Mate was talking about in terms of quality assurance, where we do a quality check at every step to make sure we have very high quality documents or high quality templates. Sorry, let me do that again. And my document again. It says avoid reflections. Okay. That is for the front page. Now it says turn my document, and we'll continue to the back page. This can also be done more professionally, of course, when I have a table just a few feet in front of me. But for now, just for the purpose of this demo, let's proceed. So I'll check my details. My name is okay, date of birth is correct, my gender is right, and my other information is captured correctly. If I have any problems with this information, I can always retake with the retake button, but let's continue. Now, it's asking me to take a selfie. Position my face, and like what Mate said, this is the magnify check. Move closer to the camera. Sorry about that. And now, for whatever reason, the onboarding has failed. But of course, you get to tell your users why the onboarding has failed. So as you scroll down, it says that gender validation has failed. So maybe I look too feminine. I don't know. But of course, if it's a failed onboarding, there's no reason that your users cannot try onboarding again. So let's try again with the onboarding, and hopefully I look manlier. I have discovered that if I frown, I look manlier. We'll see. You're laughing now. There goes the liveness check. Not so manly. But okay, we'll continue. I should do something about that. If the validation is correct and I have successfully onboarded myself, then we of course have a positive scenario where I have successfully applied for a digital identification on my mobile phone without any need to go down to a government office or to a government branch, and it's completely unassisted. Everything is done remotely at a person's home, their holiday house, in the toilet, wherever. Once this validation is done, then of course I can do other things like apply for a house, maybe buy insurance, apply for a loan, and it's all validated through this application. Okay? pass it back to Mate.
Thank you very much, Fatih. So yeah, as you can see, there are many different what we call trust factors here. Some of the most important trust factors are, of course, the validity of the ID documents from which we extracted all the personal information. Then the liveness check, which was passed in this case. So we evaluated Fatih's face as a genuine human being in front of the camera, not some sort of fake. And of course, the most important, once we can trust the document and we can trust the face, matching those two, making sure that this person is the real owner of this document. There are some additional trust factors which are, of course, optional. Some of those are age and gender validation and a few other things that we do on the background, and some of them are also indicated here in this review screen. So when it comes to age and gender detection, as an additional trust factor, we extract the age and gender information from the ID cards, because there's gender information and there's also date of birth information. So we know the real age and the gender of that person. And using the face recognition technology, we also estimate the age of that person and we detect the gender of that person in the photo. As we said, these are additional trust factors which can be used with a proper weightage based on our population, the age of the population, and so on. With teenagers, it sometimes works a bit worse, well, especially when it comes to age and gender. So this is really not something to worry about. All those factors are optional. What is much more important than that is liveness detection. As we mentioned, during this onboarding process, we used two different liveness detection mechanisms. One was the passive liveness, which was completely seamless because it was performed on the static photo, which was captured by Fatih. So there was absolutely no user interaction. He was just taking the photo as he would be taking the photo anyway. And that photo was evaluated within a fraction of a second. And the second was the magnify, which was a little bit of zoom in to one of the eyes. Now we would like to show you a scenario with not a genuine face, but a fake or a spoofing attempt. So now we are going to break it down to some steps. We are only going to break it down to a few steps. We are not going to do the entire onboarding. So now we are only going to perform a passive liveness check on a recorded video. So we have a recorded video of Fatih here. So it has good quality, it's moving, it's looking into the camera. And it looks very genuine. And now we're going to use this with the same quality assessment to check liveness. What you can see here within a fraction of a second is that this liveness check is, of course, failed. Although it looks very genuine, the quality is good, but it was detected that this photo is not from a real person. This is from a PC screen with a video recorded. The liveness check is failed again. Now, if we try the same thing with Fatih's real face, we just capture this photo, and of course, this face immediately passes the liveness check. Okay, so this was our second scenario after the initial enrollment, issuing the national ID card. The citizen activated this national ID token using a cell phone and remote identity verification, OCR to extract the data from the card, selfie capturing with liveness checks, quality checks, and eventually an identity verification against the card and the government-owned backend server. We have one more scenario to go. Let us jump back here. So we've already covered more or less everything. But life goes on, and eventually our citizen will apply for a new card because this one expires, or he loses it, or he's just trying to be tricky and apply for another one with different personal information. For whatever reason, he wants to have another card. So he visits this government office again. And now, let's say our story continues in a way that Fatih visits another government office in a completely different town, in a different part of the country, wearing a wig and trying to pretend as someone else, presenting different personal information, even a fake identity document or a fake birth certificate, trying to get another national ID card with different personal information. So now we're going to repeat this enrollment again, but this time we're going to do a very quick one. So I'm this government employee, not knowing anything about Fatih's previous enrollment. I just go through the face enrollment, iris enrollment, fingerprint enrollment. Of course, all these steps are passed because we are not doing any real-time check in the backend at this stage. But once we finish this enrollment, this backend check will be done and we'll see the result. Okay, the two thumbs are captured now. We are going to continue with the personal information. Of course, he provides different or fake personal information, trying to get another national ID card. I'm going to submit this new enrollment. And let's see what happens now. Our network connection is not ideal. So now all these information that we collected, including the images, high resolution images of the face, the irises, all the fingerprints, and all the personal information are going to are being sent to this backend server. That's why we have to rely on the internet connectivity provided by the hotel, which has its ups and downs. So what we can see here now is the new profile created for Fatih, but as you remember last time, this little flag here said unique. But this time this is not unique. This little flag says duplicate, which doesn't seem to be right. So I just scroll down and yes, I can see a hit of this record. So this tells the operator there is a potential duplicate record of this person. Although this person claims they are applying for their very first identity card, they've never had another identity card before, or they lost it and they presented different personal information, whatever, it doesn't matter, but the system says there is a potential duplicate. So I want to see it. Right? This is what we call the split screen or the biometric visual audit. And this is a user interface which gives detailed information about the potential duplicates to the operator. On the left-hand side, you can see this full biometric record, which was just captured and identified in the database. So what happened, we sent this whole record into the database, we took all the biometric data, and we performed a one-to-many check. If there is any kind of similarity between this record on the left-hand side and any other record already present in the database, it will end up on this screen before it gets approved. The one on the right-hand side is the record which was already in the database. This is obviously the record which we enrolled at the beginning of this session. So what we can see here is that the system says that these two records have very high fingerprint score, fingerprint similarity. Similarly, they have very high portrait similarity. They have very high iris similarity. I can even highlight some of the matching and the different data. So obviously this person provided completely different personal information for some reason, in some way, but obviously all the biometrics are matching with a very, very high confidence. Usually, in most of the cases, this information is enough for the operator to make a decision. So what do we have to do now? We as the operators now, we have to proceed somehow. We have to make a decision. Either we accept this report of the system and we approve, yes, this is a duplicate, we have to manage the identity somehow, or we can override it. We can tell the system, no, these are not duplicates, these are identical twins, or these are two random people with accidentally very similar fingerprints. what we have to do is some sort of identity management here. The matching result from ABIS is never the end of the story, right? The matching result must be followed up on by some identity management. Identity management means maintaining the records of a specific person within the same profile. Right? So what I do here, in case I approve that yes, these two are duplicates, and this person on the right-hand side already has a national ID card, this person on the left-hand side does not, and they want to get another one. I can make a decision to update this profile after approving that yes, this is the same person, two records from the same person. So what I'm going to do, I'm going to merge these two records. I have to maintain both records. This is very important to increase my accuracy, to maintain track record. I'm going to maintain both, but I'm going to maintain them within one, what we call biometric individual, within one profile. So after this merge action, this profile will contain two different records, two different snapshots, because this person performed two different enrollments, created two different snapshots. Right? While what I'm going to do, I'm going to archive the old record. So this old master record is going to be archived, which in my case can mean that I'm going to withdraw, I'm going to cancel the existing ID card, and I'm going to create a new master. I'm going to issue a new ID card for this person. But I can make a different decision. I can still approve this duplicate, so I can still tell the system, yes, you are right, these two records are from the same person, so I have to merge them into the same profile, because that's what I have to do to perform a good identity management. But I don't want to issue a new ID card. I just want to keep the existing master, and I want to reject or archive, or whatever status or color we use for this, the new record. So this is identity management and also some project-specific action which we have to take. Issue a new card, cancel the old one, keep the new card, reject the keep the old card, reject the old application, and so on. Of course, in case that the operator says, yeah, this is a false duplicate, which always happens. Still, according to the state of the art, there is no biometric system with 0 false rate, so we always will have a little amount of false duplicates. I can just click no match, which brings us back to the original happy scenario. So this new profile will be a unique profile, and we issue a new ID card because this person is a different person. In some very, very specific cases, which is definitely the minority of these cases, just looking at this screen is not sufficient to tell whether this person is the same or not. So if more detailed analysis is required of the biometric samples, we can always do that by comparing the photos side by side in a high resolution, which we will definitely try to do if we have some luck with the internet connection. So this is what we call the face adjudicator. This is where operators can compare these two faces side by side with a bit more details. We can play around with a little bit of the visibility of the faces. I'm just going to change it a bit just to make it different here on this combined picture. So in this slide view, I'm able to slide from the old photo to the new photo, comparing the symmetry of those two faces. This sometimes helps to determine whether these are lookalikes or the same person. I'm also able to fade from the old photo to the new photo. This helps me to explore some of the unique features and the common features of those two faces. So maybe these are identical twins. One of them has a birthmark here, the other one does not have a birthmark. So this helps the operator. Obviously, this can be a different operator, a more trained operator, to make a decision. If this is still not enough, we can always inspect the fingerprints. And I'm not going to talk about this fingerprint inspection too much because it will be presented in much deeper details in the next session about criminal and forensic biometrics. So this is what we call the fingerprint adjudicator, where we are able to compare fingerprints side by side, comparing the patterns, comparing the matching and non-matching minutia points. As I said, this is the job of a biometric expert, not every regular operator. These cases will only happen once a blue moon. Thank you very much. I think we completed all these scenarios, starting from a regular enrollment at a government office issuing a national ID card, second, third enrollment, managing those identities, adjudication, deduplication, and most importantly, an activation of a digital ID token for remote government services and digital transactions. If you have any questions, we'll be very happy to answer, and these demos will be available outside. You're welcome to approach us and try them yourself. Thank you very much.
Thank you. Thank you, Mate. Thank you, Fadil, right, for demoing. Yes, if you have any questions. Any questions? You know, since Mate opened us up, if you're shy, it's okay. We can do it offline, right? We can do it off stage. Thank you so much once again. And guys, guess what? Are you done with your lunch? How was lunch just now for you? Full, right? Guess what? We're gonna feed you more. We're gonna go for a short coffee break now. A lot of you are laughing and smiling. Like, hey, I haven't got enough of this demo. You know what? This coffee break is actually a good idea, all right, for you to grab coffee over a conversation with Mate outside. So if you have any question, this is a good chance, all right? So Mate and Fadil and his team, they will be outside at the booth, I believe. Speak to them about biometrics and see more about it. And yes, we'll come back shortly once you're done with your coffee break together with the rest of our guests who are now at breakout room. All right, and then coming back here, we'll be continuing with our last session of the day. So please stay tuned for that. Don't go anywhere, and we'll see you shortly. Thank you.